Okay, hi everybody. So I thought I would do another video talking some more about addition reactions in chapter 8. So I apologize if you hear any background noise. My son and dog are awake, and but I thought I'd just go ahead and start talking about this a little bit. So last time we started addressing Markovnikov addition and what that entails. And basically, Markovnikov addition has to do with forming a more stable carbocation. But there are instances where we see anti-Markovnikov addition, and this is going to be something important that we talk about later in the radicals chapter, but I want to introduce it now. And then we're also going to talk about what happens when we are going to add a halogen. So this is not a hydrogen halogen, this is just like a halogen like Br2 and Cl2, and how those behave when we add those into alkenes and alkynes. Okay, so let's go ahead and talk about this a little bit. This is page 4 now. So the first thing we're going to talk about here before we get into any of the anti-Markovnikov stuff is just to mention alkynes a little bit. So can alkynes add hydrogen halides? Question mark. And the answer is most certainly they can. They have 2 pi bonds, okay, and so, excuse me, this is a hydrogen atom here. This is a terminal alkyne. And if we were to treat this with, say, some hydrogen halide HX, you would see your Markovnikov addition, what I'm referring to as Mark addition. So you would add hydrogen to the side that has the most number of hydrogens, which would be the right side. Okay, so that would give you something that would look like this, and now there would be a positive charge here, which is, of course, where your halogen would add in. Now, the interesting thing about these is you can add a second equivalent of hydrogen halides. And do this whole process again. And doing a second addition, again, adding hydrogen to the side of the double bond that has the most number of hydrogens to get another Markovnikov addition, giving you this carbocation, which then if your second halogen then attacks, end up producing this compound where you have 2 halogens on 1 carbon, and these are referred to as geminal dihalides. Geminal for the twins on the same carbon. Okay, so alkynes can add hydrogen halides. Now, the follow-up question to this is kind of like what the topic was that I started off with, which is, is Markovnikov addition, is Mark addition always the major product? Is Markovnikov addition always the major product in addition reactions? And this is kind of a loaded question, and the answer is no. There are exceptions. So one exception is if we were to take, let's say, this alkene, and we were to treat it with something like HBr. Okay. Now, if we had in that solution either some peroxides or light, it was exposed to light. Light is often abbreviated as H-nu for energy. Okay, so either a bright light or some peroxides present, we would see the major product here would in fact add the hydrogen to the side of the double bond that had the fewer number of hydrogens, and the halogen would add onto the side that had more. Here there's one, and here there are two. There's the one, and there's the two. And that is most certainly anti-Markovnikov addition. So now the question here is this, well, what did those conditions, how do those result in this completely different regiochemistry? Well, the reason is because the mechanism is different. And so these promote radical, or promote what we're going to call single electron processes, okay, or radical mechanism. And that's going to be the subject of chapter 10 when we get there. And I'm going to go through the mechanism at that time. But I do want to mention it now, just because there are some questions in chapter 8 that do mention this. Don't worry about the mechanism now. We will come back to it later. Okay. Now, as far as addition reactions, our next big thing to tackle here, okay, so we've only been talking about hydrogen halides, is the addition of halogens directly. So addition of halogens, or X2, and if we had, let's say, this alkene, and we treated that with halogen X2, we would see the formation of the following product. And this product has something very interesting about it as far as its stereochemistry, and that is this is a anti-addition that occurs. So this undergoes anti-addition, meaning it's on opposite sides, okay? And this, where the halogens are on neighboring carbons, this is what's referred to as a vicinal. Vicinal for neighboring dihalide. Okay. So the way we get there mechanistically is the halogen itself is a very good electrophile, meaning it's electron poor. And so the pi electrons can react with one of the halogens, and the other halogen can act as a leaving group. So this is symmetrical, so it doesn't matter which side. So one side gets the halogen and one side gets the positive charge. Now, this species right here, which I've drawn, This is actually something that is believed to not really form very much at all. And the reason is because the halogen itself is able to close down on this. And so this species, which its existence is somewhat in doubt, actually turns into this compound here, where you have a halogen and a little three-membered ring. And you can see I've drawn the stereochemistry where these are now essentially pointing in the same direction. This is what's referred to as a halonium ion. And again, in order to form a three-membered ring, you can't have this trans. They have to both be pointing in the same direction, either both up or both down. Obviously, three-membered rings are reactive, and three-membered rings with halogen are very reactive. So this is wanting to release that ring strain. So what is going to do that is, in fact, the other halogen that was kicked out can now come in and, in fact, attack that and open that system. But when it does so via backside attack, because it's going through an SN2 process when it opens that ring system up. So this reaction, okay, is what we call a stereospecific reaction. The stereospecific reaction is a reaction where you get a specific stereoisomer. Excuse me. Okay, not necessarily one product. But you get the orientation or the direction, the approach is the same. So, okay, so for instance, if we had this cyclic cyclopentene and we reacted that with bromine, Br2. What you would expect to see here is, in fact, one isomer. I'm going to draw this where you can kind of see these in a Fisher type projection, where you have one bromine up and one bromine down. So you have this particular isomer. And you also have this compound where one bromine is down here and one bromine is up on the other side. And these two compounds, I think everybody can see, are mirror images of each other, and these are enantiomers. So what makes this stereospecific is not that it produces one of these, it is the fact that it does not produce any of the isomer where the bromines are on the same face, these syn additions, so we don't see this. Now, another way that I could have written those two out, just so that you know, this is not drawn out in this clear manner. So I'm drawing the bromine wedged up. So here you can clearly see that it's wedged up, and then the other bromine should be dashed back, clearly showing a trans product. And then here as well, one where the bromine is now going away, dashed back, and one bromine is wedged, like so. So yes, this is a fairly useful reaction in that you get this stereospecificity, which is a result of this polonium ion. Now, this is going to be a common theme that we're going to see in a couple of reactions. So this is an important phenomenon. Okay, now, I guess a follow-up to this will probably be the last thing I get to talk about. Don't want this video to be too long, is can alkynes add halogens? And the answer here is, well, yes, they can as well. They have two pi bonds. So if you were to add, say, Br2, and you only used 1 mole or one equivalent of that, one of these for one of those, you would see the trans bromo compound, again illustrating the anti-addition. And if we were to do this a second time, so 2 equivalents, second equivalent, you would end up with the tetrabromo compound, or tetrahalo, as it is known. So if you wanted to get directly to over here, all you would need to do is to use excess halogen, or Br2 in this case. All right, so now let's do a quick little practice problem here, and we'll leave it this. So let's say that we have this alcohol, and I want to treat this with Br2, 1 equivalent. And the solvent that you'll usually see these run in is carbon tetrachloride. This is a polar aprotic non-polar solvent, obviously aprotic as well, and very, very useful for dissolving halogens. So what I'd like the class to do here is, the answer is in the note packet, so you can go look it up, but I would like you to predict what the product is, and then I'd like you to try to fill in a name for that compound as well once you draw in that product. Okay, so try your hand at this, see what you come up with, see if you get the correct name. Just keep sharp on your nomenclature, and then you can check the notes for that name. I'll just tell you right now, it's on page 10 of the note packet in Unit 8, once you try your hand at this. Okay, so next time, let me just go ahead and turn this back around here. So you can see, there I am. Okay, so next time what we're going to be doing is we're going to be looking at another very similar reaction to this, except instead of just running it in carbon tetrachloride, what would happen if we did these halogenations in a solvent like water, and we actually get a completely different product. So that's what we're going to be talking about next time. And we may get to hydration of alkenes as well. But definitely get through the addition of halogens in water. So I don't want this video to get much longer. So anyway, everybody, you guys take care. I'll talk to you again soon. And just so you know, I am working on a video for talking about how exam 2 is going to be transmitted to you guys. I just need to get the rest of that set up from Sapling, and so as soon as that comes together, I will make a video about that, because I know there is a lot of stress and anxiety about that. But anyway, I don't want to talk about it too much until that is all up and running and everybody can jump on board with that and see what I'm talking about. So Anyway, everybody take care, and I'll talk to you again soon. Bye-bye.